So let's do this example one more time. So in this example, we are given 2 to 1 multiplexers, right? So these are my select signals and these my 0 to 1 inputs. So let's say my select signals are S1 and S0. So I have S1 here and S0 here. We need to use this table to understand what is going on. So what we are trying to do, so from this table, if I look at S1, right? S1 is changing either this group or this group, right? So S1 is either selecting these two or it is selecting the bottom two, right? So S1 is changing between these two groups. So then I look at here, I have I2 and I3 here, I1 and I0 here. Right, so this S1 will be controlling either the top group or the bottom group. But then let's look at S0. So if I look at S0, S0 is changing either between I0 and I1. It is also changing between I2 and I3. So then if I would like to select I2 or I3, I need to use S0. If I need to select I0 or I1, I need to use S0, right? So I look at here and the logical thing is I need to connect this here and I need to make a connection here. So this is I0 and this is I1. So to select between I0 and I1, I need to connect S0 here because S0 is from the table selecting between I0 and I1. So to select between I2 and I3, I need to use S0 here because from table I see S0 is selecting between I2 and I3. Now at this port, right, I have either I0 or I1 here, and at this port, depending on the S0, I will have I2 or I3. So either this group or this group, right? Who is selecting? So I need to make sure like, so this output is connected to this input of the mux and this is connected to the other input of the 2 to 1 mux. So between this group or this group, right? This select signal needs to be connected to S1 because from the table I see S1 is selecting either I0 or I1 or it's selecting I2 or I3. And this output will be connected to here. So after you do these connections, what you need to do, you need to make sure your connections are correct, right? Then you can try, you can give 0 0 here, 0 1 here, 1 0 and 1 1, and make sure if it is 0 0 you are selecting I0 to the output, to the Z, right? In this case you need to select I1. In this case, you need to select I2 to the output. In this case, you need to select I3 to the output. So if you try all these cases, you will see Z is getting the required inputs to output. So this example is important. You need to make sure you understand all this idea, how we are doing this select signal connections to do multiplexers. Because later on we will be doing more larger examples, and if you don't understand this example you will not understand the other ones. Okay, so if you don't understand this, go back and look at how this 2 to 1 mux is working, how to 4 to 1 mux is working, and then think about these connections and then give some values and then try to understand it. You can also try to change the connections and then see if it is working or not, right? Instead of S0 here, you can try to connect S1. But if you connect S1 here, S0 here, S1 here, it will not be working in this configuration, right? And then you can verify it is not working correctly. So you need to make sure you need to connect S0 here, S0 and S1 to do last multiplex. Okay, let's do another example. So in this example, what we will be doing, if S is 1, Y is equal to 2X, else S is 0. Okay, so this means S equal 0. Then Y is X over 2. So we will implement this using 2 to 1 mux, okay, where each input of this mux is 5 bits. So we will be having a 2 to 1 mux, but in this case, each input of the mux is 5 bits. So output of the mux is also 5 bits. Okay, so X is 4 bits and Y is, which is our output, 5 bits. Both X and y are 2's complement numbers. So how can I implement this functionality using a mux, right? We have seen if I have this if and else, so this means this is a 2 to 1 mux structure, right? Let's draw our circuit. Okay, so we will be implementing this, and so I will be having a multiplexer here. So this output is y and this is 5-bit, and I have a 5-bit inputs here. Okay, and this is my select signal. So this is, let's say, I0 with 5 bits and this is I1 with 5 bits. So what do I connect to this port and what do I connect here to get this y is equal to 2x or y is equal to x over 2. So what we can do, so let's say my x is 4 bits, right? So my x is x3, x2, x1 and x0. So, and if I have 2x, then I need to shift my x variable. So if I shift it left, then I will have an 2x, right? So then I will have x3, x2, x1, x0, and I will be adding 0 here. So this is my 2x. And how do I get x over 2? So I need to do a right shift. So now I need to shift my x to the right. So then I will have x3 here, x2 here, x1 here. So for this, so this is a 2's complement number. I need to do a sign extension to keep the sign. So this will be x3 and this will be x3. Okay. So in my circuit, if s is 0, I want x over 2. So this will be x over 2. And if s is 1, I want the output to be 2x. So for 2x, I will have 0 here, x0, x1, x2 and x3 here. For x over 2, I have this one. So I will have x1, x2, x3 and then I need to do sign extension for the other bits. So, and you will see this is working. So let's do an example. Let's say my x is 0, 1, 0, 0 and my s is 1. Then my y should be 2x, right? Which is 8. So I should get something like this. So this is my sign bit. In 2's complement, this is positive, right? So this is a plus 8. So let's put these numbers here. So if s is 1, so this is 1, then I am selecting this portion. So I have 0 here and then x0 is, so this is my 0, 0, 1, 0. So then my y will be 0, 1, 0, 0, 0. So this is 2x, right? So I put 4 here for the x, but then I got 8 at the output. So let's try another example. Let's delete these and let's get the same thing, but in this case let's make s 0. Then what will I have? So I will be shifting this. So this will be 0, 1, 0 and then I will be putting 2 sign extension, right? Because my sign is positive, so I will be put 2 zeros. So this should be what I am getting, right? I am putting 4 and then I should be getting 2. If s is 0 here, then I am selecting this side. So this is my x0, x1 and x2 and x3. So this is x1, x1 is 0, x2 is 1, x3 is 0, this is x3, this is x3. So my output in this case will be 0, 0, 0, 0, right? Because I am selecting this and I am connecting this to the output. Okay, let's do one more example. So in this example, we are given 2 to 1 muxes here. These are already connected. So I am given S1 here, S1 here, and S0 here. I want this to implement a 4 to 1 mux. So S1, S0, this is Z. So I want this functionality. So given this, so we have our inputs here, I0, I1, I2 and I3. So in this example, I would like you to do the correct connections for this 4 to 1 mux to work. Okay, so this is 4 to 1 mux, but inside we have 2 to 1 muxes. Okay, so this is 2 to 1. Some connections are already given. And these are S1, S0. The select lines are already connected, but you need to do the input connections correctly such that I will be implementing this truth table, right? So how do I make sure these inputs are connected correctly? So let's check these connections. For the case 0, 0, 0 and S0 is 0, I need to select I0, right? So if S1 is 0, I will be selecting this one. If S1 is 0, I will be selecting this one. So S0 is only selecting the upper one or the lower one. So I0 either needs to connect to here or it needs to connect to this port. But which one I need to connect, I don't know right now, right? But from these connections, what I see, this S0 is either selecting the top one or the bottom one. So if S0 is 0, I should be either selecting I0 or I should be either selecting I2, right? So in a way, this line I should be getting I0 or I2. But for this one, which is selected when S0 is 1. So if S0 is 1, then I am selecting this line. So, and I check from the table, if S0 is 1, I am either selecting I1 or I am selecting I3. So this should be I1 or I3, right? So I know I should have I0 and I2 here, and I should have I1 and I3 here, right? From the table. And then, so what I see here, I have S1. So S1 is selecting for this mux, it should be selecting I0 or I2. Let's look at S1. So if S1 is 0, I am selecting this line if S1 is 0. If it is 0, I will be selecting I0 and I1. But I have I0 and I2 here. So I should be having I0 connected to here. And then, so if S1 is 1, so this is the case for S1 is 1. It is selecting I2 or I3. So, but in this group, in the top group, I should have I2 here. So this is I0 and I2 is connected to here. And for the bottom case, let's look at the bottom one. So if S1 is 1, which is this line. So if S1 is 1, I need to select I1 or I3. But from the table, I see I3 is here. So I3 is connected to this line. So if S1 is 0, then I need to select I0 and I1. So if S1 is 0, I am selecting this one. So in this case, this should be I1. Okay, so this is how I did the connections for this 4-to-1 mux, right? So I0 goes here, I1 goes here, and I2 goes here, and I3 goes here. So in this example, I just change my select lines. Then I have to also change my input connections such that I implement this table. Okay, so let's do another example. In this example, we will do an 8-to-1 mux using 2 4-to-1 mux and 1 2-to-1 mux, right? So let's write down the functionality table. So I need to implement this 8-to-1 mux with this functionality table. I have 2 4-to-1 mux, so I should use these 4-to-1 muxes here, and then 1 2-to-1 mux. So this is my Z. So the most logical thing would be I will be putting I0 here, I1, I2 and I3 here. So I will be putting I4, I5, I6 and I7 here, right? For these select lines, right? Let's say this is my select lines. Let me give them another name. Select lines A1 and A0. Let's say this is also A1 and an A0. So for these select lines, for A1 and A0, I need to connect some select lines such that it is selecting between I0, I1, I2 and I3. If I look at the table, which select lines are changing between here, right? So if I look at this part, if I use S1 and S0, they are selecting I0, I1, I2 or I3. So I will be connecting S1 and S0 here. Similarly, to select I4, I5, I6 and I7, I can use S1 and S0. So I will be connecting S1 and S0 here. So now I can have I0, I1, I2 or I3 here. Similarly, I could have I4, I5, I6 and I7 here. So which signal is selecting either this group or this group? So if I look at the table, there are two groups. This is one group and this is another group. And between these two groups, only S2 is changing. Either S2 is 0 here or it is 1 here. So I can connect S2 here and this will function as a 8-to-1 mux. Here you can try, for example, 1, 1, 0, right? So for this case, I should be selecting I3. And then these are 1 and 1. So I select I3 here, 1 and 1. I select I7 here. So I have I3 here and I7 here. And then my S2 is 0. Then I select I3 here. So for the case of 0, 1, 1, my Z is I3, which is correct, right here. So you can also check the other ones and then you can verify this is working. So let's do another example. In this one it says design an 8-to-1 mux using 1 4-to-1 mux and 4 2-to-1 muxes. So in this case I will be having 1 4-to-1 mux and 4 2-to-1 mux. So 4 2-to-1 mux, then I can have 8 inputs. So I will be putting these 2-to-1 muxes to the left because I will be having 8 inputs for this one, right? So I can connect I0 here, I1 here, I2, I3, I4, I5, I6 and I7. So this is my select signal for this. And then I have 1 4-to-1 mux. So then I have these 4 outputs and these 4 outputs should go to this 4-to-1 mux and I have Z here, right? So let me write the table again, functionality table. So let's look at here. So which signal changes between I0 and I1? So I look at here. So S0 is changing between I0 and I1. Which signal is changing between I2 and I3? I2 and I3 S0 is changing. I4 and I5 S0 is changing, right? And I6 and I7 S0 is changing. So I will be connecting S0 here for the select lines for 2-to-1 muxes. So either here I will having I0, I1 here, I2, I3 here, I4, I5 here and I6, I7 here. So between these groups, which signal are changing, right? So this is one group, this is another group, this is another group, this is another group. So if I look at here, so I have 0 0 here, S2 S1, 0 1 here, 1 0 here and 1 1 here, right? So this is 1 1 for this and for S2 S1. So this will be S2 and this will be S1. So this is 0 1 2 3. So let's check whether this is working. Let's try case of S2 S1 S0. So let's check 1 0 1, right? Z should be in this case I5. Let's check this. So this is 1 and I have 1 here, 1 here, 1 here, 1. So I have I1 here and I have I3 here and I have I5 here and I have I7 here. And here I have 1 and 0. So 1 and 0 is this one. So I will be connecting this. So what is this? This is I5. Now I select my I5 to do output. So you can try other cases and then you will see it is working. So let's do another example. So in this case we will design an 8-to-1 mux using only 4-to-1 muxes. So again let me write my table. So in this case I will have 4-to-1 muxes. So to get 8 inputs I will be putting these 4-to-1 muxes here. So this will be, I will connect I0, I1, I2 and I3 here and I will be connecting I4, I5, I6 and I7. So now I need to select either this output or this output. So I will be putting another mux here, 4-to-1 mux, because I am only allowed to use 4-to-1 muxes. And this will be my Z. So how do I do the connections here? So again I need to find out these select lines. So for these two lines I need to find the signals that selects between I0, I1, I2 and I3. So from here I see S1 and S0 is doing this. So I will be connecting S1 and S0 here. Again from I4, I5, I6 and I7 I can use S1 and S0. Now let's see how do I connect this. So I have an upper group and then lower group. So upper and lower group I can use S2. So I have only S2 here. So S2 will be either selecting this one or it will be selecting this one. So if I connect this to here and this to here, so this is 0, this is 1. So how do I select this between 0 and 1? I can put S2 here. So if S2 is 0, it will be selecting this one. If S2 is 1, it will be selecting this one only if this is 0. So this is how I can do this. So I put a 0 here and I put S2 here. Now this could be either 0 0, it could be 0 1. If it is 0 0, I will be selecting this line. If it is 0 1, I will be selecting this line. So this will work, right? So this is not the only solution. So let me do it again with a different connection. Let's say I could have connect this to here and connect this to here. So this is 0, 1, 2 and 3. So in this case I need to have either 0 0 here or 1 1 here, right? So how do I achieve this? Using S2. So I need to do this with S2. Then what I can do, I can connect S2 with both of them. So if S2 is 0, then I will be having 0 0. If S2 is 1, then I will be having 1 1, right? So there might be different solutions, but this is only 2 of them. So you can try different connections with this multiplexer inputs and the select line for the S2.